Hi everybody, this is the do now for day 84, and it's a little bit of mixed review, so I thought it was important to do it because we do have the finals coming up in a couple months, so I want to make sure we're not forgetting any of our old stuff. All right, so the first question is, how many solutions? And again, you can find these blanks on my website. Don't forget, mrsrimbos.weebly.com. So how many solutions? That means that we are going to have to solve it. Don't forget your DCMS distributes. So 3x plus 20 equals 3x plus 12 plus 8. Remember, your C means to combine. So you can combine like terms, or there's no like terms to combine on this side. And on this side, you can combine your two constants. So that's 3x plus 20 equals 3x plus 20. Remember, you have to move the variables first when you're doing counting solutions. You have to, because you can't compare unknowns in math. You can only compare your constants. Okay, these are constants. So see, they're exactly the same, and that's going to be infinitely many. If it was 0, it would be something like this, like 6 does not equal 2. If it was 1, it would be like x is actually equal to 6, and 2, well, that would be our systems of equations. You know, when you have like your two systems, like 3x plus 4y equals 10, and 2x minus 6y equals something like that, 2 letters. So it is choice D. Speaking of systems, all right, number 2, a group of students are going on a field trip. Those that have a coupon will pay $30, and those that don't pay $40. The school collected $1,500, and there are 60 students. So remember, all the money has to go together. Okay, money plus money equals money. So 30, 40, and 1,500 have to be in the same exact one. So 30, 40, nope. 30, 40, 15, 30, nope. 30, well, just from the first one alone, you know it's B. And this down here is the number of the people that have the coupon, the number that don't, and the total amount of people. So those are your two equations. All right, and last one. The equations represent a pair of blank lines. So this was a long time ago, but if you notice, and if you were to graph them, okay, if you were to take out a piece of paper and you were to graph these, there's positive 10, negative 6, you would notice that they would look like this. So they are parallel lines. Well, how do I know they're parallel lines without even graphing? Right there. Same slope, different y-intercept. So these are going to be parallel. And then because they are parallel, they have blank solutions. So do these ever intersect? Nope, they never intersect. Because they never intersect, that means there are no solutions. Okay, that means there are no solutions. So remember, we have a couple different kinds. So this was called our inconsistents. Inconsistent are our parallel lines, and there are no solutions. And that's the one that looks like this. Same slope, different y-intercepts. Then we have the one that I put on the test. This was called consistent or intersecting, and this is where there's one solution, and that one solution is where they obviously intersect. And that could be something like this, where it's different slope and different y-intercepts. And then the last one, if you remember, this is called our dependent. Basically, you have a line, and then you graph the other line literally right on top of that line. And this is our infinitely many solutions. And this is basically the same exact line because they're the same slope and the same y-intercept. So same slope, same y-intercept. All right, hopefully that helped for today's do now. Bye.